All right, hey everybody, welcome back to Chemistry 2. We're going to talk a little bit about nuclear fissions and how the nuclear bomb itself works. A lot of it's classified, a lot of it can't be discussed, but I'll break down what I can. And I know for some of you, you're kind of like, hey, what's this redneck dude in a cowboy hat going to tell me about nuclear fission? Well, in a previous life, weaponry was my subject. I taught it for more than 2 decades. So I'm going to bring out a teaching aid, a scale model replica. This is a replica of an RPG-7 rocket-propelled grenade. This is a Chinese variant. Now, obviously, none of this is real because it's been cut away to be a teaching aid, right? But the overall mechanics and the gist of how this works are the same. So when they loaded Big Boy up and were headed to Japan to drop her, one of the first things you'll see people do, especially in the movies, is remove the cap or arm the weapon. So we take the cap, and what you see here is a fuse, right? And you'll see it go to about here. Now, as we go through this, we'll talk about how the fuse itself actually works and is part of the process, because the fuse, as many people know or don't know, we'll put that back on later, is essentially a tiny bomb. A blasting cap is in here. It's a tiny bomb that will set. On the back side, you have another explosive system. So as for this, because it's a rocket, as it burns down, it'll get to this point here where it'll set off this fuse or this burn. Whichever happens first. It may explode from impact, or it may burn out and set it off here. Either way, that's why RPGs are not, you don't just see them typically as dud rounds. After 900 meters, they'll explode in midair. But we're going to come back to that. Now, what you do see is packed explosive. Again, this isn't real, but if this were a real RPG, this would be the explosive piece, also known as the warhead piece. These are shaped as a cone, but you can imagine if this was Big Boy, it would be packed with uranium, with explosive matter and uranium right here, where the yellow is, as well as another portion of uranium right here. So now you're saying, well, Paul, how does that actually work? What difference does that make? Well, nuclear fission is pretty simple. It's pretty cool. This blast, initiating blast, happens back here, right? It could be set on a timer. It could be set on a burn. It could be set really kind of however they want to set it. But the initial explosion happens here, and it is a traditional explosion. But what it does is it takes uranium-235, and that explosion causes that uranium-235, which is the important piece, to do what? So uranium-235 is generally kind of coated around uranium-238. Now, 238 itself, not that big of a deal. But all of a sudden, when this explosion happens and these uranium-235 particles fragment and shoot out, it's going to cause what is known as a chain reaction. And basically what that means is that in a chain reaction, one of those fragments comes in, hits another molecule, and it splits apart, right? So now we got 4 floating parts. All 4 of those floating parts will then go and hit another particle, and that will explode. So as this thing kind of pyramids, if you will, you're right, because 1 block becomes 2 blocks, 2 blocks becomes 4 blocks, 4 blocks becomes 8. It pyramids. That is what causes rapid nuclear fission, or in this case, a rapid nuclear explosion. These explosions are typically, or not typically, they are known to be one of the greatest explosive ordinances on the Earth. It can take out the Earth. There's enough nuclear explosive on planet Earth to, I think it's like 36 times. It could take out the entire planet. There are, however, other bombs out there that are, or other ordnances out there that are of a higher yield, right? So explosive yields are based off of TNT or dynamite, if you're not that familiar with explosives. Dynamite is the standard, right? So it could have one yield, or as it grows, the actual word escapes me right now. But as it's measured, the atomic bomb's measured against TNT the same way the C4 is measured against TNT, the same way anything is measured against TNT. But there are bombs or weapons that we have at our disposal as the United States that are of greater power than the atomic bomb, as you know, is nuclear fission. And that'll be a conversation for a different day and a different crowd. For now, I appreciate you tuning in, listening to what I have to say on a very quick breakdown of how nuclear fission works. If I had more time, we could get into a lot more detail, but I wanted you to grasp the overall concept of how the bomb works and how it creates the nuclear fission itself inside of the warhead. So with that, have a good weekend, and I will see y'all next week.